Hello ladies, it's Mr. O'Sullivan. Today what we're going to be doing is we're starting a new unit, linear functions. So we're going to be looking at linear functions for the next week or two. Today's learning target is I can apply the properties of linear functions to determine key information about my function. Before we go into some problems, what we have to know is we have to understand what a linear function is. So a linear function is a function whose graph is a line, and it can be identified in equation form in that there will be no exponents in the equation. So for instance, the minute I have this in my equation, it's not linear. So we need to make sure that every time we see this exponent, it's not linear. The way to identify a linear function from its equation is just to look to see if there's an exponent. How to identify a linear function from a graph? Well, the graph is a straight line. Look to the right. The red line I just drew in and the black line I drew in are examples of linear functions because they're just straight lines. It's all right. And then how to identify a linear equation from its table of values or a set of points? Well, there's a constant rate of change. My y values are increasing by the same value and my x values are increasing by the same value. The average rate of change of a linear function is actually pretty special because it's always going to be constant. And it has a special name because of this, and we call it slope. So you've heard slope before. The slope formula is delta y over delta x. That little triangle is the Greek letter delta, which in the math world just means change. And whenever we talk about changes, we're always talking about subtraction. We also can write it as y2 minus y1 over x2 minus x1, where the x1, y1, x2, y2 are just points in your line. Okay. The y-intercept is where your graph crosses the y-axis. We're going to be going over all of this. You might think I'm going extremely fast, but we're going to be doing problems very shortly. So here's an example of a y-intercept. So in this visual to the right, I have my y-axis and my x-axis. So my y-axis, not sure what happened. If I look, I have my y-intercept and my x-intercept. My x-intercepts I can call my x-intercepts, my roots, my zeros. I can also call them my solution. Your x-intercepts are where your graph crosses the x-axis. You're going to hear myself, Miss Townsend, and Miss Jimenez say these words all interchangeably. Okay? So you have the y-axis and the x-axis. Your y-intercept is where your graph crosses the y-axis. So for instance, this is an example of a y-intercept. And you always write your y-intercepts as 0, comma, y. So basically to find your y-intercept, you plug in 0 for x. Your x-intercept is somewhere like here. It could be here, it could be here, it could be here. And we write these as x, comma, 0. So you plug in 0 for y to find your x-intercepts. And there are three forms of a linear equation or function. There's the slope-intercept form, which is the one we're going to be primarily working with because it tells us the most information. The equation of the line is in y equals mx plus b form, where m is the slope and b is your y-intercept. Point slope form, the equation for the line is in the form y minus y1 equals m times x minus x1, where m is your slope and x1, y1 is basically any point on the line. Standard form, this one's just the annoying one. It's only really helpful to help you find your x and y intercepts, which we'll go over eventually, but it's basically where a, b, and c are constants. So it just sort of looks like a mess. Whenever we're given an equation in standard form, what we typically do is we try to get it into slope-intercept form so we can find out what our slope is. The first page, it's not slope-intercept, it's not standard, it has parentheses. Whenever I have parentheses, it's going to be point slope. Back to my point slope form, the number attached to my x's is my slope. Go to the front. It's not in y equals mx plus b form. It's not in the y minus y1. It is written in the form where my x comes first, my y comes next, and then I have a number. This is the standard. On our first page, I said this. If you have a straight line, something that looks like this, or something that looks like this, it's linear. Let's do some problems. So answer the questions based off the equations provided. So it looks like a lot, but I promise you it's actually relatively quick. So let's go through it. Example number 1, we have y equals 2/3 x minus 6. Question A says, is it a linear function? Well, yes, it's a linear function because there are no exponents. If I look, I don't have an exponent here, I don't have an exponent here. Well, this doesn't really matter because that's a number. As long as my variable doesn't have an exponent, I'm good. So, yes, this is a linear function. Part B says, if it is linear, identify the form the following linear equations are written in. So for instance, if I go back to my notes before, this looks like it's written as y equals mx plus b, where m is my slope and b is my y-intercept. So I can say this is written in slope-intercept form. This is written in slope-intercept form. If it is linear, state the slope. Well, if I look at this, my slope is the number attached to my x value. So the number attached to my x value is my 2/3. So I can say my slope is 2/3. D, if it's linear, write the equation in slope-intercept form if necessary. Well, it's already in slope-intercept form, so I'm just going to rewrite the equation. Y equals 2/3 x minus 6. And then E, if it's linear, state the y-intercept. Well, the y-intercept is the number hanging out by itself. And if I look in, the number hanging out by itself is a -6. So my y-intercept is -6. And this is very important because we need our slope and we need our y-intercept to graph. All right, let's go on to our next example. Is it a linear function? Well, I look at my x and there is no exponent, so yes, this is a linear function. If it's linear, identify what form the following linear equations are in. Well, if I go, so this is written in point slope form. If it's linear, state the slope. Well, if I look, my slope is going to be a 3. If it's linear, write the equation in slope-intercept form if necessary. I promise you this is not as daunting as it looks. What I'm going to do is I'm going to copy and paste that equation from above. So we have our equation y minus 2 equals 3 times x plus 2. Whenever you want to write it in slope-intercept form, you want to get it to look to be just y equals on one side. So you want a y equals an equation. So what we're going to do is we're going to distribute our 3, and we're basically going to solve for y. Distribute my 3, distribute my 3. I get y minus 2 equals 3 times x is 3x. 3 times 2 is 6. And now I want to get my y by itself. And if I look, I have a minus 2 over here. The only way to get rid of a minus 2 is to add 2 to both sides. So what I'm going to do is I'm going to add 2 to both sides of my equation, just like this. My 2's are going to cancel, and I get y equals 3x plus 8. And that's my equation. So that's my equation in slope-intercept form. Now, if it's linear, state the y-intercept. Well, if I look in point slope form, I can't really find out my y-intercept is by looking at the original equation. So what I'm going to have to do is I'm going to have to look at the equation I just constructed. So if I look at this equation, my number hanging out by itself is the 8. So I can say that my y-intercept is 8. Part A. I have this equation, 5x minus 2y equals 16. I have to ask myself, is it a linear function? Well, yes, it's a linear function. My x doesn't have an exponent, and my y doesn't have an exponent. So yes, this is a linear function. Part B, if it's linear, identify the form it's written in. Well, hanging out by itself. So we call form of writing a linear equation. So we're going to put in standard form here. If it's linear, state the slope. Well, here's the issue. I actually can't do that just yet by looking at it, but we can do it shortly. So we're going to skip C for now. If it's linear, write the equation in slope-intercept form. Well, it's not in slope-intercept form. So what we're going to do is we're going to rewrite this equation and we're going to solve for y. Pay very close attention because this is going to be the level of difficulty I expect you to do 99.9% of the time. So I have this equation, 5x minus 2y equals 16. Again, if I want to get it into slope-intercept form, I want to get it into y equals form. So what we're going to do is we're basically going to square or circle this negative 2y and say to ourselves, don't move it. Don't touch it, just leave it where it is. So I have to ask myself, how do I get this 5x to the right-hand side of my equation? Well, if I look, it's positive, so the only way to get rid of a positive 5x is to subtract a 5x from both sides of my equation. So I'm going to subtract 5x, and I get negative 2y equals, and always put your x first, because we want it to be in mx plus b form. So we always want to put our x first. So I have negative 5x plus 16. Now I have to look at my negative 2y, and I have to ask myself, how do I get rid of my negative 2 attached to my y? Well, I want to get y by itself, so what I'm going to do is I'm going to divide each and every single term by my negative 2. So I'm going to divide my negative 2y by negative 2. I can divide my negative 5x by negative 2, and divide my 16 by negative 2. Well, my negative 2's are going to cancel, so I get y equals negative 5 over negative 2. Here's the thing. A lot of you are going to type this into your phone, and you're going to say, Mister, it's 2.5. Yes, it's 2.5, but what I want you to do is leave it as a fraction. As a fraction, this is just going to stay 5 over 2. So this becomes 5 over 2, and then I put my x next to it. And now I have 16 divided by negative 2. 16 divided by negative 2 is a negative 8. So I have y equals 5 over 2x minus 8 as my final answer. Now I can do part C. If I look at this equation, the number attached to my x is my slope. The number attached to my x is a 5 over 2, so I can say my slope is 5 over 2. Now, I can also state what my y-intercept is. My y-intercept is the number that's just hanging out by itself, and the number hanging out by itself is a negative 8. So I can say my y-intercept for this equation is negative 8. You're probably about to say, why are we doing another one of these? Well, it's actually straightforward. I have to ask myself, is this a linear function? Well, I got an exponent with my x. It's not linear. The minute you see that exponent, it's not linear. So it's not linear because of the exponent. We can't do B because it's only allowed to do it if it's linear. We can't do C because it only works if it's linear. We can't even do D because that only works if it's linear. And even E because it's not linear. So we can't do any of these questions. We will know how to do these questions in a few units, but we won't know how to do them today. First page. We're going to find out what all this information means in each situation. Okay. Example 2. Answer the following based off the graphs provided. Again, you're going to notice that one of them is linear and one of them is not linear. If I look at this, I don't know if it's a linear function. So let's look at my graph. This is a linear function because it is a straight line. So we're going to say, yes, this is a linear function. And you're just going to write straight line. If so, what is the slope? Well, you're going to be using slope as rise over run whenever you look at a graph. So you have to look at this and say, ooh, okay, so I have my original point right here. and you're going to count your rise over your run. So you're going to count your jumps. So here's how I approach. I count my jumps. Let me get a marker. I jump 1, I jump 2, I jump 3, I jump 4. So I'm going down 4. 1 second. Let me grab my eraser. I go down 4. So that's a -4. And now I need to figure out how much I'm running. I run 1, I run 2, I run 3, I run 4, I run 5. I go to the right 5. So my slope is -4 over 5. And remember, it's rise over run. What is the y-intercept? Well, your y-intercept is where you cross the y-axis. Remember, this is my y-axis, this is my x-axis. So I cross the y-axis right here, which is the point 0, 1, 2, 3. So you can say your y-intercept is 3, or you can say the point 0, 3. What are the roots of the function? Well, the roots are your x-intercepts. If I look, my x-intercept is somewhere right here. It's where it crosses the x-axis. It's right here. So I go 1, 2, 3. It's sort of like 3.5. And again, it's not 100% correct. So my roots are 3.50. Or I can just say x equals 3.5. And up here, how I just wrote 3, I could also say just y equals 3. Now, if it's linear, write the equation in slope-intercept form. Well, this is actually very straightforward, I promise you. We know this slope-intercept form of writing an equation is y equals mx plus b. Where m is our slope. And b is our y-intercept. So I have y equals we said our slope was going to be -4 over 5. So I have -4 over 5 x and my y-intercept we said was 3. So my equation is -4 over 5x plus 3. And that's your equation in slope-intercept form. Let's go on to the next set of questions. So for this one, since we have a graph, we can actually answer a bunch of the questions, but the first thing we have to ask ourselves, does this represent a linear function? And if I look, it's definitely not a linear function. This is not a straight line that's always increasing or always decreasing. So we're going to put no. And in a few units, we're going to learn about what type of function this is. So I'm not going to tell you just yet. We can't answer part B because we don't have a linear function. So we actually can't find the slope of this function yet because our slope is not constant. So we can't do this. We can answer the y-intercept though. Our y-intercept is where we cross the y-axis. So we cross the y-axis right here at -3. So I can say -3 is my y-intercept. So I can say y equals -3. Or I can say 0, -3. Because remember, your x value comes first and your y value comes next. Part D, what are the roots? The roots are where you cross the x-axis. So if I look, I cross my x-axis right here. And I cross it here as well. So I can say my roots are -3 and 1. So I can just write down x equals -3, x equals 1. But if you want to be very sophisticated, you can write them as ordered pairs. You can say -3, 0, And you can say 1 comma 0. Remember, the way you can remember to put your 1 first is because, look, you're saying x has to be equal to 1. Well, that's an x value. You're saying x has to be equal to -3. Well, look, boom, that's an x value. And we cannot do e because this is not a linear function. We will go over what type of function this is in the next few months, based off of a graph. And our final part of the lesson today, we will be doing, so the way this lesson was structured was, we're showing you what we're doing this whole unit. We're going to learn how to write the equation of a line. We're also going to find out how to write the equation of a line based off of a table of values. So whenever you're given a table of values, the first thing I want you to do is find out how much you're jumping by. And here's what I mean by jumping. Don't even look at the questions yet. Just find out what your jumps are. So when I jump from -1 to 0, I go up by 1. When I go from 0 to 1, I go up by 1. When I go from 1 to 2, I go up by 1. So my change in x is 1 everywhere I go. My change in y, though, I go from -1 to 0. That's a +1. I go from 0 to -1. That's a -1. And if I go from -4 to -3, that's a -3. Here's the issue. If I look at this, my jumps are not the same. So whenever my jumps are not the same, I'm not dealing with a linear function. So does this graph, ooh, that's a typo, does this table of values represent a linear function? Well, the answer is actually, no, it doesn't represent a linear function because my jumps are not the same. And we can't do this because we don't have a constant rate of change. What is the y-intercept? Well, your y-intercept is when x equals 0. So if I go to my table of values and I go to x equals 0, well, my y-intercept is 0. So my y-intercept is 0. So I can write y equals 0, or I can just write it as an ordered pair, 0, 0. What are the x-intercepts of the function? Well, the x-intercepts are when y equals 0, so if I go to my table of values, I have a y equals 0 right here. So that means my x-intercept is this exact same as my y-intercept. So I have another 0. So I can say x equals 0, or I can write it as an ordered pair, 0, 0. So just give you the heads up, it's very much possible that your x-intercepts and your y-intercepts could be the same. Is it every single time? No, not really, but it is possible. And if it's linear, write the equation in slope-intercept form. Well, it's not linear, so we can't do it. So we're going to just do a big old no. Now let's look at this one. So you might think, ooh, it doesn't look like it's linear. Well, let's look. The first thing we do is we find our jumps. Let's find our jumps. Find those jumps. When I go from 0 to 2, I go up by 2. When I go from 2 to 4, I go up by 2. So it's looking good so far. When I go from 6 to 3, I go down by 3. When I go from 3 to 0, I go down by 3 as well. So if I look, I have the same change in y each time, and I have the same change in x each time. That's beautiful. That's exactly what I want. So I can say that this is a linear function. So I'm going to say yes. If so, what is the slope? Well, we know our slope is y2 minus y1 over x2 minus x1, or we can just simply say our slope is the change in y over the change in x. And when I talk about this change in y over change in x nonsense, what I mean is your jumps. So if I look for my y values, I was jumping by -3 each time. So my delta y, or my change in y, is -3. And my delta x, or my jump in x, was a 2 each time. And it was a +2. So I can say my slope is -3 over 2. And that's your final answer. Part C, what is the y-intercept? Whenever I get this question, I always underline it. And I write down, well, it's when x equals 0. So when I go to my table of values, I look to see where x is 0. Well, x is 0 right here. And when I plug in 0 for x, I get a 6. So what I'm saying is my y-intercept is 6. So I can just write down y equals 6. Or you can write it as an ordered pair as 0, comma 6. And that's your final answer. What are the x-intercepts of this function? Well, the x-intercepts are when y equals 0, so if I go to my function, y equals 0 right here, so my x-intercept is going to be a 4. So I can say x equals 4, or I can do 4, comma 0, just like that. Now, if it's linear, write the equation in slope-intercept form. Well, we know our slope-intercept form equation, I'm going to go through it all over again, is y equals mx plus b. And that's an equal, not a minus, where m is our slope, and b is our y-intercept. So when I write this equation, I have y equals, my slope we said before was -3/2, and it is a -3/2, so you can't just write 3/2, because that will be wrong. I then put my variable for x, and then I add my y-intercept, which we said was a 6. So my equation is -3/2x plus 6. And that's your final answer. We are doing so much practice with this over the next few days. So tomorrow we're going to go over how to graph. We're going to spend 2 days on graphing. Then on Wednesday, we're going to go over how to write the equation of a line in a different situation. So we're going to basically spend a day on each situation. Then we're going to do some word problems. If you have any questions, please email myself, Ms. Townsend, or Ms. Jimenez. And don't forget to do your Delta Math assignment. Have a great day, ladies.